Welcome everyone. The question is, a PN junction is forward biased. As a result, option A is both the potential barrier height and the width of the depletion region decreases. Option B is both the potential barrier height and the width of the depletion layer increases. Option C is the potential barrier height decreases and the width of the depletion layer increases. Option D is the potential barrier height increases and the width of the depletion layer decreases. Okay, this question comes in CBSE 2025 physics question paper. Okay, as a MCQ. But before just tick which one is the correct option, let me try to understand what is the basic behind it. Okay, so I have drawn the PN junction. Let us say this is the figure 1. Okay, when the PN junction is formed, at that time the depletion layer is created. Okay, the P type of material have the majority carrier holes. Okay, majority carrier holes are there. Okay, and the N type of material have the majority carrier electrons. Okay, so what will happen when these two type of elements somehow fused? At that time, what is the necessity for the P type is available to N type? What is the necessity to N type is available to P type? P have the deficiency of electrons and the N type have. So what will happen? The electrons are basically moves from the N to P side. Similarly, N has the deficiency of holes, so the holes will move from P side to N side. Now try to understand that neither P type neither N type semiconducting bar is a positively charged or negatively charged semiconducting bar. Remember that the P type semiconducting bar is made by fusing trivalent impurity within the germanium lattice or silicon lattice. Similarly, N-type semiconducting bar is made by fusing the pentavalent impurity within the germanium lattice or silicon lattice. Okay, so what will happen? What will happen when the negative electron moves from the N side to P side? A positively charged ion is formed on the inside. Similarly, when the hole is moved from the P side to N side, a negatively charged anion is formed there. Okay, and this is not for the one. A numerous number of positively charged and negatively charged cation or anions are formed on this border. Okay, and on this border region, it is completely depleted of the carriers, that means the holes and electrons. The holes and electrons diffusion takes place, and that's why the positively charged and negatively charged immobile acceptor and donor ions are created just on the two sides of the junction. Okay, so what will happen as the region on the two sides of the junction is depleted of the carriers, holes and electrons? So we can say that this junction, the region around the junction or on the both sides of the junction is called the depletion region, this much, and it have obviously certain width. Okay, obviously, then what will happen? This depletion region is formed, but it is of this much or little bit more than that, but it is not that this region is expanded the whole bar. Okay, it is not happening. Okay, it is not happening. Why it is not happening? What is the reason behind that? Because when the hole from the p side try to enter to the n side, it will see a positive potential barrier is developed. Because the positive charges are there, it will repel it, so a positive potential barrier is developed. Similarly, when an electron try to move from the n side to p side, at that time you will see a negative charges wall is there, a wall of negative charges there. So it will can't enter into the p side. So after some time the further depletion stop and the width of the depletion region is fixed. Okay, but if you increase the doping concentration, then obviously depletion layer for the different p-n type semiconducting bar will be different. Okay, so on the n side we can say, if I draw the potential versus x graph, so it will be something like that. On the n side a barrier is developed and that is the constant. Okay, and on the p side this potential barrier is developed and it remains constant. Okay, this is a negative one, negative potential, and this is the positive one. Okay, try to understand that if you want to measure the potential barrier developed across the junction or the potential barrier of the depletion region, it is not possible to measure by the help of the voltmeter or any other instrument which is basically operating on the working principle on the moving coil. Okay, in the moving coil instruments what will happen, a north pole and south pole pieces are there. Try to remember this thing what you have learned. This is the north pole and this is the south pole, and in between them a rectangular wireframe or any other different types of different shapes of wireframe is kept. Okay, the current enters into this wireframe. Okay, and due to this the deflection occurs and it will, the pointer attached to the wireframe basically shows this reflection and you are able to measure the current flow or the potential difference like this way. But here when the potential barrier on the two sides of the junction is developed, at that time what will happen, further diffusion of the electrons and the holes will stop, and when it has stopped, then what will happen, no flow of carriers, no flow of charge carriers, current is not flowing, the current flow is stopped. So you cannot measure the potential difference developed on the both side of the junction or in the depletion region with the help of our phenomenal voltmeter, galvanometer, or any other instrument. Okay, now it is said that if the PN junction is forward biased, okay, the PN junction is forward biased, that means the p side of the junction is connected to the positive potential and the n side of the junction is connected to the negative potential. Okay, and here is the junction. Okay, now the question is asked, what will be the how the depletion region or the barrier potential has changed if you have done this. Okay. We know that the current is flowing, that is electrical energy is flowing within the metal. Obviously, why I am saying metal, because obviously it is connected to a battery like this way. Okay, it is connected to a battery. So what will happen, from the negative side electrons are flowing and the electrons are entering from this side. Okay, and the positive holes, which is the phenomenal one, obviously it is not obtained in the metallic conductor, it is obtained only in the semiconductor. Okay, so we are not talking about that, but what will happen, we can consider it when it positive from the positive side, the holes are fused, and from the negative side the electrons are fused. Now just think of on the two sides of the barrier, what will happen, it comprises of lots of negatively charged ions are there, sorry, positively charged ions are there, immobile ions that cannot move from space because it have lost its electrons, it have given that electron to the p side by the process of diffusion. Okay, so the positively charged are there. Similarly, lots of negative charges are there on the both side of the, on this side of the junction, and it basically stops further diffusion. Okay, so we can say very simply that the electron from this side basically neutralize these positive charges. Okay, and making a depletion layer width small. Okay, and the barrier potential has decreased. Okay, how it is, let me show this. If previously it is the PN junction, if previously before doing forward bias, if this is the width of the depletion region, okay, then after the PN, after connecting the P side to the positive terminal of the battery and the N side to negative terminal of the battery, its width has decreased because some of the negative charges on the N side and some of the positive charges on the P side is somehow they are getting neutralized. Okay, so the barrier potential is becomes less. As the barrier potential becomes less, so if you what will happen, further diffusion of holes and electrons on the both side will again result in, okay, so you can see the current flow through the diode. So if the diode is forward biased, at first the potential barrier is decreased, the width of the depletion region is also decreased. That means both has decreased. So option B is the correct option here. Both the potential barrier height and the width of the depletion decreases, so that the current flow increases. And if you continuously increasing the potential of the battery, if you are able to do that, then more width will decrease, more width of the depletion region will decrease, and potential barrier will decrease, and there will be more flow of the current. Okay, and if you do the reverse scenario, then what will happen, then obviously the width will increase, and if this width will increase, the potential barrier height will increase. If the potential barrier height will increase, then what will happen, further diffusion of current or the further current flow through this conducting bar will decreases, or after a certain value it completely cuts off. And that's why the diode can be used as a rectifier, and it can be used for the unidirectional current flow. Okay, so option B is the correct answer. Thank you all of you.